Hello, everyone. We're going to let folks get logged in here, so give us a minute. So glad you guys could join us today. I know folks are going to keep coming in, but I'll go ahead and get us kicked off here. My name is Monica Lee. I'm the Marketing Director for Viscosity North America. Good morning, good afternoon, wherever you're joining us from today. Today's webinar is co-hosted by the New York Oracle User Group and Oracle partner Viscosity. And we're super excited to have Oracle ACE Director Jim Czuprynski presenting for us today. So I'm expecting to see some great questions from the audience. This is a live webinar, so feel free to submit questions. A little housekeeping rules for you guys. There is a chat section, but if you have a question for Jim specifically, please put it in the Q&A field. If you have any questions about Zoom, about logistics of anything else, you can put that in the chat and I will try to get to you when I can. Otherwise, Jim will monitor the Q&A section and he will answer your question as soon as he can. And if not during the presentation, he can get to it afterwards. So real quick, a little bit about Viscosity North America. If you're not already familiar with us, we are a full Oracle stack consulting firm with a core expertise in Oracle database. We touch everything on RAC, Oracle Apex, zero downtime migrations, performance tuning, high availability. We've had decades of experience with Oracle infrastructure, including engineered systems. And lately, we've still been converting a lot of our customers or upgrading them, I should say, to Oracle Database 19c. And we also host monthly workshops through orapub.com, including our next one, which is actually a Oracle 21c upgrade workshop happening on March 17th. So check that out if you're interested. But otherwise, I'm going to hand this over to Coleman, who is part of the NYOUG board. He's going to tell you a little more about NYOUG, how you can get involved, and how to follow them.
Thank you, Monica, for the kind introduction. We were formed almost 40 years ago for the exchange of ideas, assistance, and support among users of Oracle software products. We're always looking for more abstracts. You can go on our website, nyoug.org, NYOUG call abstracts. You can connect with us on Twitter, Meetup, and of course the abstracts, LinkedIn, Facebook, and our website, nyoug.org. And I want to thank Viscosity for co-hosting these series of webinars, which are going to be coming up to about 2 years in a couple of months. So thank Viscosity for co-hosting this with us. And I want to turn it over to Jim, who needs no introduction.
Well, thank you. Yeah, actually, I probably do need an introduction. So I'll introduce myself. Just kidding. Good morning, good afternoon, everyone. I want to say thank you very much for having me here today. I've always enjoyed working with the NYOUG, Coleman and his team, of course. And today, I'm going to talk about something that is really not database specific, okay? It's really more in a kind of a gray area. What we're going to really do is take a look at Oracle Graph Studio, and that's why I call it Oracle Graph, right? And talk about how we can use graph databases. Now, everybody's probably heard about things like Neo4j or any of those things, right? And what I've been noticing, by the way, is as, let me make sure I'm actually moving on here. There we go. Sometimes screen sharing just doesn't work quite right. And I'm going to cut my video for right now, so we have plenty of bandwidth, if that's okay with you guys. Let me just do that. Stopping my video. Can everyone still see me okay? I hope so. If my audio goes away at any point in this presentation, I accidentally did this about 3 weeks ago at RMUG and found out that no one was able to reach me in time. So for 5 minutes, I was moving slides around and no one even realized it. or I didn't realize that I had lost audio. So please do let me know if you do that, right? Just to hit me in the chat or whatever. But for right now, a little more about myself. What do I do these days? Well, technically I'm on sabbatical. I hate retirement. I hate that word. I spend a lot of my time really as a technical advocate these days. In fact, I was just 2 weeks ago at a cloud field day for an organization called Gestalt IT, where I was actually listening to vendors present to me, which was a departure, right? So I spent a lot of time in any technology space available. Most of my days, winters in Illinois, this is pretty much what it looks like today. Summers in Wisconsin, that's probably in June. Usually the snow melts by then. I'm an amateur bird watcher, love watching different species of birds. My wife and I even traveled as far away to the Galapagos. That was actually something, a hummingbird, one of the 18 species we saw in about 30 seconds in the cloud forest in Galapagos. I'm not a very good athlete, as you can see here. I'm usually getting my butt kicked by the oldest person. I'm actually the second oldest dude in the martial arts class. I'm usually getting my butt kicked by the oldest person, and that's my wife in my martial arts class. I've written a few books and stuff like that, but you can reach out to me at Jim the Y Guy. Follow me on Twitter. I usually have something interesting to say, and please do connect up with me on LinkedIn. Also, I will mention this, that I have the opportunity to podcast every once in a while. And if you want to check that out, take a look at beyondtechskills.com. My colleague Lira Nemitzi and I drop an episode about every 2 weeks on Wednesdays. We talk about everything, you might guess, everything except tech. We talk about the things that everybody ignores, soft skills, the things that really, truly do make you successful. But enough about that. Let's talk about property graphs. Let's get to the big picture here first, okay? If you're a DBA or a developer, right? Especially if you're a DBA or, you do a lot of work with databases, right? Traditional RDBMSs use SQL to play with data in sets. And here's a typical type of relationship. We'll dive into this a little bit more later, right? I got a bunch of bank transactions, right? People are writing checks. They're transferring money between accounts, right? So I might have, think of your own personal business, right? That you conduct. You might be taking money from a credit card account and moving it over to paying a bill with that, or using your checking account to pay the credit card account, right? And of course, every single account has an owner, right? If you have a retirement plan and you have a spouse that has a retirement plan, right? You might have a Roth IRA, a 401k, maybe a rollover IRA from rolling over your past employer's accounts into that, right? But these are typical types of what we might call entities, right? We think about data in that regard. And that's really good if you're trying to say, show me everybody that has a transaction that's more than $1,000 for an account that's owned in my personal range. Oh, and by the way, owned by my wife, right? That's easy to do. And of course, you could expand that concept out to any type of transactions that you might have, right? But here's the thing. What if you're trying to figure something else like this? Given a particular bank as a starting point, tell me if a bank other than the account's owner has received funds from another bank owned by someone in a different country. If you're following the information war that's accompanying the tragedy of what's going on in Ukraine, I have a cousin in Poland, in Krakow. He's 3 hours away from the front lines, okay? And they're helping millions of refugees come into Poland. Poland's been amazing. They just basically said, we don't care if you've got documentation. We'll take care of you. We understand, right? But if you've been following along what's been going on with the oligarchs or the kleptocrats, depending on how you feel about them, right? There have been massive interest in this, especially if people are passing money back and forth, because that's how kleptocrats launder money, right? They basically take funds from some other bank and manipulate it, change it into maybe real estate, change it into charitable donations, and then eventually send the money back to themselves via circuitous route. And this is a lot easier to do in a graph database. It's much harder to do with SQL in a traditional RDBMS. That's the big picture. That's where we are right here. Now, let's think about something else, something that, if you want to think about this from a different perspective, right? Let's talk about it from the perspective of something like Netflix, something like whatever your streaming service is, right? Let's think about it's Oscar season, right? So maybe Netflix decides we're going to start a campaign to promote some movies. And we're going to do it in two ways. We're going to promote Oscar winners. So if you haven't seen The Power of the Dog, by the way, it is the strangest and most wonderful Western that I've seen in a long time. If you get a chance to see it, it's quite interesting. I won't even describe it to you. Marvelous performances, right? But if you don't like, as my cousin likes to call those, that's not a movie, it's a film, and you just want to see something action related, a friend of mine recommended Nobody. That's the name of the movie, right? With the same guy that plays Never Call Saul, right? So maybe Netflix is going, yeah, I know there's a bunch of people that like film, and then there's people who just want to see somebody get their head kicked in. Okay, well, let's go and watch Nobody. It's just escapist violence, right? Let's be honest, that's really what it is all about. So what they're trying to do is promote that. Well, we got people in here, cats eating popcorn. I love that little logo, watching movies and going, man, I saw Nobody. And, I tell a friend, who tells a friend, who tells a friend. And maybe I've got one person that's a real cinephile or really enjoys martial arts or whatever, right? They recommend to a bunch of other friends, but another friend starts watching it and goes, I don't like this. I want something that is a little escapist, maybe a little bit of violence, but I want something, older. So I'll watch Gran Torino. Now, here's the interesting thing about Netflix. You may or may not know about this. They don't rate movies anymore about who watched it so many times. What they're using as their criterion is how many hours watched, how many unique eyeballs were watching for a particular hour, because that's what they're interested in. Because if you're watching that, you really can't watch something else. But we also want to get buzz going, right? Maybe they got a promotion for Nobody or a promotion for, hey, if you watch Power of the Dog this week, right? Amazon Prime does this all the time, or at least used to, 99-cent videos, right? Get buzz and people go, oh man, that's a great movie or whatever it might be. So not every subscriber watches the recommended movie, right? I mean, that's not the way it works, but maybe they watch something in that same genre, right? Okay, Gran Torino and Nobody, kind of in the same genre, definitely not in the same power of the Dog genre. But you notice what we're talking about here? It's not about how many hours watched. We haven't talked about that except for one time. We're talking about here is how are these data connected? And that is the essence of what we call property graphs. So why are you getting into this, Jim? Well, let's take one specific example. Here we go. I got 4 Excel spreadsheets. This lands on your desk. It's your first couple days at a major New York City bank, or maybe you work for Interpol or whatever. Quickly now, tell me, based on these accounts and the transactions happening here, is there any evidence of money laundering? Time's up. Now, if you're a traditional Oracle DBA or applications developer, you're going to go, oh, I'll take this and I'll load it up into a table. And there's obviously keys here that I can look at. And I'll try to figure out, I can do this in a graph database with one PGQL statement. And I'm going to show you that in just a second. I can take these data and prove to you that something hanky, as we say here in Chicago, hanky, like it's not kosher, my friend. Something's going on. You know what I mean? That's how we look for corruption. So how do I get to this? Well, Oracle has something called Graph Studio, and I'm not going to spend a lot of time on these slides. In fact, I'm going to skip through most of these because I'm going to show you live how this actually works. So I'm going to come over here to my Graph Studio home, and I'll bet you I'm still logged in, and I am. So here's the cool thing. This is built on, by the way, on top of Autonomous Database. I'm using an ATP instance. You could also use an ADW instance. I haven't tried it with AJD yet, but I'm pretty sure you could. And here's the idea. I have several different things I can do. I can build models of what? Of how data are interconnected. Not tables, folks, property graphs. And that's what you've actually got here. Notice I've got 4 right here. I'm going to build one real quickly in just a second. Well, so what? Well, here's what. I can do Zeppelin notebooks. Now, again, since I'm inside Autonomous Database, we know it's going to be something very similar to how Oracle's machine learning environment, OML, works, right? So these are Zeppelin notebooks. Well, I don't like Zeppelin. I want Python. I want to do it in Jupyter notebooks. You can't do that right from here. But Oracle has a PGX tool set that lets you plug into Java or Python or a few other tools. So if you want to do it beyond this, there are ways to do it. I'm going to stay here because this is easy. And by the way, free. It's part of the always free layer, right? An autonomous database. By the way, this will consume some cycles. So be aware that $300 a month free might get consumed pretty quickly. And I'll explain why in a minute. But let me show you how easy it is to create a graph. So I'm going to come in here and I'm going to go over to the models section. And I'm going to say, dear Oracle Graph Studio, I'm logged in as a user called AGD, get it? Autonomous Graph Studio, fraud, not frog, fraud. Remember that commercial? Yeah, I was just looking at that a few days ago. So I'm going to create a new model and I'm going to use tables in AGD fraud. And the ones I'm going to pick, and I'm going to talk more about this a little bit later, are 2 tables here. Twitter members and Twitter payloads. And I'm just going to move those guys into here. And over here, Oracle confirms that I've certainly looked at them. And now I'm going to move on to the next step. Oracle's going to go in here and automatically look at relationships between these tables. And by the way, one of the concepts, a key concept, if I will, inside graph databases is the concept of vertex and edge. Let's translate it into plain English. Forget vertex for a minute. When I say vertex, you think node, a point, right? And when I say edge, think about vectors coming out of those nodes. Kind of like that graph I just showed you with all of the, remember the movie influences that we were looking at. You know, somebody liked this movie, suggested it to someone else, right? The people or the recommendations or whatever could all be nodes, also known as vertexes. And then the direction as well as the strength, and you can actually have a strength, if you will, right? A metric of how strong this relationship is. A lot more about that coming up. Is the edge, the thing that connects the nodes. Anyway, Oracle's come back and said, oh, cool. I see that Twitter payloads is probably going to be an edge, and Twitter members is going to be a node, a set of nodes. Oh, okay. Can you show me a little bit more about that, dear Oracle? Yeah, let's see what's inside the Twitter payloads table. And I just clicked into that and it says, well, here are some of the things that are actually part of it. There's a message text, a type, an originator, a resender, polarity, subjectivity. Huh, how interesting. I can also, by the way, if I wanted to right here, drill into the data and get a better view on it. Twitter members, a little different. Twitter members, who do you think that is? People tweeting. And I have information like, what's your Twitter handle? What's your Twitter ID? What time zone are you registered in? What country are you registered in, right? By the way, those things are meaningless for Twitter. Twitter says, here's where the tweet originated. You may not be living in Ukraine, Russia, South Africa, the United States, or Canada. You could be anywhere, but it recognizes where the tweet originated from based on IP address and other things, right? Also, notice I got some other attributes, followers and following. How many people are following this Twitter account? How many people are actually followers of this Twitter account, right? So these are the kinds of things. And how did Oracle know to pick this out? Here's how. It knows that that Twitter ID in this table here, in the table that underlies that, Twitter members, has a foreign key relationship over to Twitter payloads. And so it built a model for me automatically. And finally, Oracle says, great, I've got this. And again, if I wanted to, I could actually, oh, by the way, I mentioned this here, right? If I wanted to drill into some of the data, I could actually do it right here. And I can see some of the data from this, and you can see that, okay, everybody's got a unique number. They've got a handle, deplorable 123, eagle 1001, right? A time zone, etc. So that's the actual data. I could look at the actual tweets that came out as well, but you get the idea. Right now, Oracle has said, based on foreign key relationships between these two tables, I can make a model. And you know what? And from there, I can create a graph. And I'll just call this testing, and I'll call the model mod testing, and for fun, something like that. And I'm going to create a graph type called property graph view. And Oracle goes, oh, can you please load that into memory for me? And there's a few other options here, but I just want to show you how easy this is. So what is Oracle going to do? First thing it's going to do is create a property graph. Underneath the covers, by the way, a property graph, and you can see here, Oracle is, I'll make that a little bigger, is creating it, right? Property graph is essentially the way they implemented a bunch of tables, except with all the things that show, here are the nodes, here are the vertices, I'm sorry, nodes are vertices, I said that the wrong way, right? Nodes and the links between them. And so in this case, it said, all right, I will load a graph from that PG view into an in-memory representation. Notice it also, this was there a little earlier this morning because I actually, oops, it did not succeed. Well, we'll go back to that for just a second. Sometimes that happens. I'm going to come back here and try to load that graph back into memory. Here's my graph. Notice I got several other property graphs that are no longer in memory, and I'll have to load them back in. But I'm going to load this guy into memory right now. Hopefully I'll have enough memory to do it. Why is this all being done in memory? Because unlike traditional, there we go, kicked it back off. Hopefully this will work. Unlike traditional database tables, these guys are computational. Okay, being nasty, aren't you? Okay, well, I'll come back to that. I loaded 4 other graphs in memory just fine. I had no problem doing that. Let me just make sure I can do that. I'll come back to my graphs and load up the ones that we really need for our example here, which is right here, because these I need for my samples. Yes, yes, yes. Go ahead. And the idea here is Oracle needs to do this in memory, mainly because of the incredible amounts of computational resources. Well, she's being picky. I'm going to log off and log back in. Hopefully that will clear my memory space, and we'll go ahead and get back in here. I do have slides showing how this all works. Trust me, it really does work. Tom Kite once said, never do live demos. And now I know why. Seriously, we should be having no problems here. Here was my model that I made earlier. Here's one of my other models. I'll just come back over here to my graphs and load those guys back up. It'll take just for a second. Let's load up this guy for sure, because we're going to need him right away. And it should create that memory area again, recreate it. Perhaps it might be a little thirsty for memory. In any case, we'll see how this goes. It should be okay. The idea here with in memory is that the computations that are happening, these are extremely, well, this guy's being persistent. That's why I have slides. These graphs, right, take up an enormous amount of computational space, because we're essentially doing stuff in n-dimensional analyses, and that's why they need to be loaded into memory. We'll come back to this in a minute. Let me go shift over to my slides, because I am fully prepared for my slides to replace the video demo that didn't exactly work. So I already showed you all this, right? I showed you at least how it's supposed to work. And then I showed you this, right? I'm creating a particular new graph, property graph from existing databases and tables. And essentially in this case, I did a slightly different one we're going to use in just a couple of minutes here for two other tables called accounts and transfers. And then, as I showed you, I could look at the data inside, or I can look at the attributes for each one of these. I can look at either the edge or the vertices. Remember what I say? When I say vertices or when I say vertex, you think node or nodes. Remember that. Okay, so here are the edges and here are the nodes. Nodes, edges. And in this case, by the way, you'll notice that I can quickly go take a quick look at them and notice that I've got an owner ID and I've also got an account ID, right? The owner ID is specific to a human. The account ID is specific to an account that's owned by the owner. So already I've got a foreign key relationship there too. What I actually did is I transformed this, as you'll see in just a second, into a view. I can also use views, by the way, instead of tables, but that does add a little bit of complexity to creating this. And as I showed you here, I created a new graph. I gave it a model name. And unlike what I showed you a few seconds ago, it actually did finally create a graph and load it up into memory. I can also, by the way, if I know how to do create property graph statements, this is a special side of PGQL, property graph query language. It's really kind of like DDL for property graph query language. I can also specify the create property graph statements. Essentially, when I did that with the model and I created the graph, this is what Oracle executed under the covers. This is the code it actually references. And so taking a look at this here, I've got a node table called account summary. Actually, it's not a table, it's a view. And in my case, remember I told you I had accounts and owners. So I glued together accounts and owners just for a quicker way, an easier way to experiment. I glued together the information about the account owner, the country they were in, and the accounts that they own into a view. And I included that as the node. What are the edges? Transactions. And notice that the transactions, I've got other things there. I've got the amount of the transaction, the date, a memo, what it was for, the type of transaction, and two account numbers. A source account, where is it coming from and where is it going to? And notice that the source key, this is part of direction for a property graph, right? The source key, source account ID, references the node, AGD fraud account summary. And the destination key also references it. Yeah, because I've got a starting account, Jim's checking account, and the destination, Jim's retirement account. So what? Here's what. I built another graph, a little bit more complex, called FP complex. Same idea, basically. I originally had FP simple there. FP simple was simpler. It only had two tables. FP complex, you know that code I just showed you, where I used a view to essentially denormalize two of the objects, two of the entities. That's using this FP complex. And here's the key point, folks. Remember I said, could I come up with and try to map out? Is there money exchanging hands? Is it going in a circular relationship? Check this out. PGQL, PGX is essentially a declarator for, here's what I'd like you to do inside Graph Studio, dear Oracle. I'm selecting the account name and the transaction amount from a node, account summary, show me all the nodes that are in that, and map it to their edge tables and produce a graph. Let's go see if I can load this guy back up, because I would really love to make sure that this is working. me see if I think I can retry. Let's try that. There we go. This is, by the way, is another tab here called jobs. And so I can run jobs at different tasks, right? Notice I said, hey, please load FP simple. And it goes, well, wait a minute, dude, I need an environment to do that. So I'll go create the environment. This is quite sweet. Can I use code to do this? Yeah. Can I do it in here? Yeah. Do I end up at the same place? Yeah. So let's see if this actually does work. And then I'll actually show you the notebook and how we did it under the covers. If not, I still got my slides. By the way, if you're asking questions, if you can throw them into the Q&A, I'll come back to you as soon as I can. I'm sure you probably do have a few questions here. I'm just going to take a quick tea break to wet my throat a little bit. This looks a little more promising. We might actually get our environment created. Of course, this is the first time I've tried this in half an hour and it worked fine. So here I am trying to show you that, oh yeah, this is really stable. It actually is. I've had very rare cases where I haven't been able to load a graph and I may have just overwhelmed it with that third request a little bit. Okay, this time it created the environment. That's a good sign. Probably the memory needed to get cleared out, right? Because it does allocate, I'm not kidding, 14 gigabytes of memory. That's a big chunk of memory in a little container inside my ATP environment, right? Now we have a memory. Now we've got a graph. I'm going to go load one more graph in there because I want to demonstrate this one too. And that's FP complex. Let me load him up real quickly. Come on, baby. Load graph into memory. Okay, we'll let that go. And let's take a look at some of the notebooks as soon as that clears. There we go. So I created, as soon as that clears, I'll show you. I love doing this in live as much as possible. I built one notebook called fraud detection examples. So here's the graphs. Now, if you've worked with OML, you know that Zeppelin and almost all notebooking technology has the concept of notebooks, right? Of paragraphs inside that notebook. So I could display a whole bunch of little things here, but what I just want to show you real quickly, notice this is some stuff from earlier. Here's an example of essentially that same graph that I drew you, right? Can you see the code here? So give me the account name, that's the node. E.tx amount is the edge, right? So that'd be the transaction. The node is essentially stuff about the accounts. And notice I used the FP simple graph to do that. And look what I get. I get this marvelous little graph here. Let me come down a bit and show you that. And this is a graphic representation of, there we go, what's going on, whoops, let's make that a little smaller, inside my accounts. And you can see that some of these have lines pointing to and from them, and they've got little attributes here. And, oh, this doesn't really tell me anything, Jim. Yeah, I agree. It doesn't. It's quite confusing. But this is the default graph that actually Graph Studio chose for me. But I'm going to get a little more sophisticated. In fact, I'm going to dive into this a little bit more. And I'm going to say, you know what? Show me, check this out. For accounts and their owners, show me how many times they moved transactions out and how many times transactions came in. And here's an interesting pattern. Notice account 10101, which is named Ilyich Trust Rollover IRA, had 10 transactions out and none in. And Ilyich Investment Holdings had 11 out and 2 in. And there's a bunch of other ones here, right? Several others. I just showed you the first 5 here, I think, on this page, but I could go to the next page as well and show you, oh, there's all kinds of interesting things happening here. What, huh? So things are being moved around inside here. Huh. Okay, cool. But here's a fun one. I did a little bit more research and I figured out that any of the accounts that end in 01 are essentially legitimate. Show me how the money's moving. And this is another example of a graph. And so let's start right here with this light green guy. Actually, let's start right here with Judy Ruliani, who did some sort of transaction and sent a bunch of money over to another account owned by Judy Giuliani, who then sent a bunch of money. Well, wait a minute, why does it say 3 here? Because I told the graph, let me just show you my properties here, which are right here, I believe. I want to change the way I'm displaying some things. Instead of collecting similar edges, I'm going to say, show me everything. Ah, that's what the 3 means. 3 separate transactions went from Judy Giuliani to Roman Ceausescu. Oh, okay. And notice, by the way, they're all type RFC. That is a retirement fund contribution. Wait a minute. Judy Giuliani is making retirement fund contributions to Roman Ceausescu, which, by the way, if you look at the data on Roman, I'm going to switch back to our original setting there, collecting them. Roman lives over in the Czech Republic. The heck? Oh, and then note that 2 transactions went to Vladimir Ivanovich, if you're Russian, or actually if you're Slavic. Ivan Ivanovich is kind of like John Doe, is what it comes down to. Oh, and then he did 1 transfer to Jakub Wojciechowski over here in Poland, who did 3 more to Fraud Assurance, who then did 5 back to, and 3 back to, what? Yeah, Judy Giuliani's laundering money. That's what this really says. This is certainly suspicious. And note, my friends, I did that with 1 statement after a little bit of research. That's how this worked. This is the power of graph databases, right? Of looking for the relationships between the data and trying to map out, well, are these important relationships, and be able to filter things out. Make sense? I hope so. So that's really how we could use this for fraud. And there's other details here. And if anybody's interested, I'm certainly more than, I want to actually get this in the live labs. I've had the people at Oracle go, can you get this in the live labs? Because these are really good examples. And I'm like, yeah, I guess we could do that, right? To show some of this. But again, PGQL is not just for graphing, it's also for querying and things like that. So I hope that makes sense. I'm going to go back to my slides for a bit, because we've already talked about this, right? With 1 graph and 1 statement, I'm able to go, something hanky is going on here. Remember, the arrows are pointing the direction that the transactions are going. Well, I could do that with SQL. Yeah, but would it be as obvious? No, probably not, right? I showed you in degree and out degree, which are analytic functions. More coming on that. Stay tuned. I also showed you this graph again after I filtered out those accounts. And it was much more obvious that something going on with Judy Giuliani here. I don't know what she's doing. I can also, by the way, I showed you this real quickly. Hey, I can say, you know what? I know the names are kind of long, truncate them at 25 characters to make it easier to see. I can also, I showed you this, right? I said, heat edges versus collect them all together. I can set the size. I can set different analysis patterns, and I'll demo that if we still have time. And I can even say things like, hey, if this thing is going in a particular direction and there's a particular code associated with it, would you please change the color? And I showed you that in that other graph. So hopefully that all makes sense. What I want to share with you now is one other example. Let me come back over to my spreadsheets here. I should say my notebooks, and I'm going to load a couple more graphs because there's a real fun one we've got here. I think I just need this one. And this one's a little bit more interesting. This one, notice, by the way, FP Simples in is showing up as being inside memory right now. And I think we'll just stay with that one for right now to avoid any issues. And what I'm going to do here is talk about another type of thing that we can do. And I'll demo this real quickly. This was interesting. This was actually on NPR that they looked at, and again, I don't really want to get into masking and vaccines and pro or con, okay? All I'm talking about is information flow. And NPR published this as a result of another article in which they basically said, show me the nodes on Twitter and on Facebook where most of the, again, based on that organization's judgment, where most of the incorrect information about vaccines was coming out, right? So whether vaccines work or not, I'm not talking about that. I'm talking about people were saying things about vaccines that simply weren't true based on their judgment coming from the CDC or other organizations, right? And by the way, notice I've got my friend here, Amazing Misinformation. If you're a South Park fan and you remember episode 4 from season 4, which was, believe it or not, almost 25 years ago, he ran a health foods kind of a naturopath store. And she kept telling everybody, no, Kenny's not sick. He really needed a new kidney. But she said, no, Kenny, if you know South Park, Kenny dies in every episode, right? Kenny's really sick, but no, that's a sign that he generally gets better before, I'm sorry, he generally gets worse before he gets better. And it was great because people would say, wow, that's amazing misinformation. And Kenny dies. He dies in every episode, but especially in this one, right? What if I was looking for not whether the information's true or not, but just who's spreading it? That's what they actually did, by the way, with Facebook. And it was quite interesting. And yeah, they narrowed it down to just 12 key accounts on Facebook. Now, again, I'm just saying that's the research they did. Could I do that with Graph Studio? Heck yeah. One of the things to know about is that Oracle built into Graph Studio a bunch of other graph algorithms that let you do things like, and I'll show you a little bit of this, walk a graph, right? So not just that Judy Ruliani transferred money to, or then who then transferred, but also things like how far away are these nodes from each other? How tightly clustered are they? And so forth. And as we're going to talk about in a little bit, there's machine learning algorithms as well. So again, I mentioned the Graph Client API. You can access this completely separately without using an autonomous database or even Graph Studio. You can build some really amazing stuff with this. I have not gotten that far yet, okay? But just to give you an idea, some of the ones that are here, and I'll show you this one in just a second. There's one that basically says, okay, I'm looking at all the nodes in the graph. Which one's most important? Based on the number of incoming edges. A perfect case for that would be, I've got a website with 35 pages on it. Which ones are constantly being hit? We're actually doing some of this analysis for ODTUG, by the way, to figure out from our website, who's going to what pages the most and why or why not. And then I've listed a couple of other ones here. I do like the WTF one. No, it doesn't, not that WTF. It stands for whom to follow, right? And I haven't played with this much yet, but basically it's the idea of you want your tweet, you want your Facebook post, you want your whatever to get out, and you want it to go out positively to influence your social standing. In other words, be noticed. You know, essentially you're not sitting at the nerds table anymore. You're one of the popular kids. You can actually use an algorithm to see that, right? So I built one here, and let's go over, I'll demonstrate this one for live, by the way. So I'll come back over here, and I'll just come in here, and I'm going to go over to social media patterns. I think these all use network complex, right? And so what I did is, remember I told you I had a bunch of stuff that was Twitter members, right? People that were tweeting, and then what they actually tweeted out, and what they actually were talking about, right? Well, this graph might be a little hard to see, but we'll see if we can get down in there. You can see that there are some people, let's see if I can move this guy over a bit. Yeah, let me go back to my smaller scale. You can see that there's essentially here, if I could drill into it a little more effectively, that there's one person who's really starting out a ton of tweets, and then it's being spread out throughout the network, right? So essentially these guys here are the most influential people, right? And then everything else is kind of downstream. By the way, why are some blue and some red? Because we're actually able to, with particular algorithms, determine if this is more, shall we say, politically left of center, blue, as we like to code in the United States, or red, more politically right of center. And we can actually do these kinds of analyses, by the way. Some other interesting things here. I can also show the data of what the polarity and subjectivity is for each one of the tweets that were sent. And notice I've got an originator and a resender. And that actually gives me an idea of who is retweeting positive or negative tweets, right? If you think about what's going on in the Russia-Ukraine war right now, right? You got people who are trying to amplify or amplify messaging, right? Negatively or positively. So someone, may send a negative tweet, somebody else might pick it up and try to turn it to a positive. And so you can actually measure these things, right? Quite fascinating. Let me scroll down a bit more here. But here I did the same in and out degree thing. I'm not going to burden you with that. I just want to show you this real quickly. This is an example of a page rank algorithm. So I'm going to run this for a second. And notice these take a blink of an eye to run in most cases, right? And if I want to see, I believe I should be able to see the output here. Where's my output? Let me run that one more time. It should be showing my output here. Oh, it did it. I'm sorry. It actually applied the page rank to it. If I want to see it, sorry, I'm just going to show you the top 12 nodes, vertices, based on that page rank algorithm. And what you'll see here in a second is, here are the people that are essentially the biggest influencers, right? Notice below that, I've also got stuff for, and here they are, right? So here are the people that are listed, right? What their page rank is. Notice they've got a certain number of followers and so forth and so on. But this guy here who decided to pick deplorable 1003 as his Twitter handle, actually has the most influence, and then decreasing from there, other people, right? I can also apply different analytic functions, which I'm not going to go into. I just showed you some of those, to the same graph and calculate some stuff. And then once that's done, notice it's all done. I can come in here and run this and see things like how many followers a person has as compared to how important they really are in the network. Okay. One other thing, I'm going to come back up here for a second. Remember I showed you this thing and it's like your eyes are hurting from this. One other really cool thing is I can change the settings on this graph. Let me just show you that. Right now, I am using a layout called hierarchical to display this. What happens if I pick something else? What happens if I pick, for example, concentric? Check this out. Now I've got a totally different view of who is, let me make that a little bigger if I can. There we go. Who is at the center and who's at the edges of the graph. Folks, that was with one mouse click. I just changed the viewpoint, right? Let me do another one. I'm going to change this to, let's see, what have we got here? Oh, customization. I'm going to change this to, let's pick the default, which is what's called force, which is this guy basically saying, just give me something that makes sense so that I can understand how this stuff is being displayed. Oh, and one other thing too, I can also cut this out and display it directly. Let me just show you how to do that. I can display this as what's called an iframe. I can do that right from here, I think. Yes, I can say just break this out as a separate frame. And now I can change the settings a little bit more selectively if I want to. I've just opened this essentially as a web session, right? Or I should say as a web page. And I can look at just this if I want to, okay? So we're getting close to the end here. I want to wrap up here. I showed you this already. I showed you how PageRank and several other things work. Finally, to wrap up, because we're well beyond where I wanted to stop today, there's also 4 machine learning tool sets built in. And if you thought machine learning tool sets outside of PGX is hard, check these ones out. I actually had to go do some research to figure out what is the best usage of these. This one, the third one down, is fascinating to me. It's called unsupervised GraphWise. You know how we got machine learning algorithms for doing all kinds of analyses of data between things? This one is actually being used with a 4D MRI brain scan of a new patient coming into a psychologist or a psychiatrist or a neurosurgeon or a neurologist who says, you know, we've got people that we know are very, very far out on the autism spectrum disorder spectrum, right? And we got people that have normal brain scans. What if we could take a child, hell, an adult, that we suspect may have some sort of disorder on that ASD scale and compare it and look if there's any differences or any similarities? Because I have friends that have autism, their children have autism, right? And trying to figure out exactly what's wrong and what's right and how severe they are on the spectrum is extremely difficult and very subjective. This is a fascinating look at where we might be going medically in the future. Where am I going with this? Well, in the future, I want to actually play a lot more with the PGX tools in native mode. All I need is time. If anybody wants to sell me an extra day per week, I'd be interested in hearing about it. I want to play a lot more with social media data. That whole idea of only 12 influencers really spreading either correct or incorrect information is fascinating to me, right? Imagine if I could do that in real time. You know, there's an old saying that truth, that a lie runs around the world, travels around the world 3 times before truth has a chance to put its shoes on. Wouldn't it be great if we could nail those kinds of things down and go, no, that's not what's happening, right? Especially think of the current conflict in Ukraine, right? Misinformation could send us into World War III. We want to make sure we're getting the right type of information. And I also want to play around a lot more with these machine learning algorithms because they sound fascinating to me. Will I get time? I sure hope so. Remember, on sabbatical. So we'll see what happens. And with that, I do have a couple of things. I will send you this presentation, Coleman, I'll get it to you. I have 8 minutes left. I actually have more time than that. But I do have some great little documents and some great little examples, links to that. But for now, I'm going to stop sharing and see if anybody actually wants to talk to me. So anybody have any questions? Let's pop them into the Q&A. I don't see any questions right now. Or you can ask me, can we open people if they want to ask verbal questions, guys? Is that possible? You can't see my face. Well, we'll fix that. Here's my smiling face. I hope you enjoyed that. That's a lot of fun. That's a lot to go through, by the way, in just a couple of minutes. Okay, I see a couple people in chat. Is that people just saying, show your face? Okay. Nobody wants to ask me a question. 100% comprehension.
You guys have this time with Jim. Take advantage of it. And if anyone
had a little more
forming a
time.
question,
Yeah,
I do want to remind everyone that this was recorded and it will be available at aurapub.com, where if you're not already a member, you can sign up to be a free member and you will be able to access this webinar and so many more. And you can rewatch them as many times as you want in there.
Helena, thank you very much. Yes, I think it was very informative. I assure you, it's actually much more stable than that, by the way. Usually I've had no problems doing presentations. I think I overwhelmed my environment a little bit, but what can I tell you? Okay, and you guys know where to reach me.
All righty. Well, if that's it, thank you so much, Jim. Thank you to NYOUG as well for putting this webinar on. For Viscosity to co-host. We're always very excited and happy to co-host with NYOUG along with other user groups around the country. We are big supporters of user groups. So if you are not from the New York area, look for one near you. There's always cool stuff going on and people are going back in person. So you might get to see presentations like this during a lunch and learn, during a conference, during something like that, a monthly meeting. So check them out and thank you all.
Thank
Thanks,
you, Jim.
Jim.
You're welcome.
Take care, everyone.
Recording stopped.